All right, welcome. We are continuing on in book club, and because it's summer, we have a lot of people attending virtually. So I appreciate Elliot especially being here in person. No pressure, no pressure. We are getting into really the meat of the task, and so I'm just going to dive right in. So I'm going to go ahead and share my screen. Where we are now is we're really in what is, in my opinion, the most actionable parts of this book. We are in part 3 and part 4. And again, because this is a new paradigm, the author correctly is presenting conceptual before practical. It is interesting though, because I actually have built now a POC for a customer, my first one. And maybe because of building the practical, I feel like all of chapter 9 is very difficult to transform into business value because it's so high level. And I really was working more at the level of chapter 10. That being said, I think there's value in chapter 9, but what I'm going to do is I'm going to hit the highlights, kind of like I did in part 2, and then augment my discussion with a demo, because I know for me, this is such a large topic that without this sort of real world grounding, I find it to be a little too high level for me to, like I said, create business value. So that being said, I'm going to just dive right in, and you can see that we're in logical architecture, and the high level topics are data sharing interfaces, this fancy word of architecture quantum, which, okay, fine. I'm a linguist. I can go for, you want to have a word that reflects the many possibilities, but it's a little bit fancy. The multi-plane data platform, and then embedded policies. So some of the things in here, again, I'm a very visual person, and so I'm really liking some of her drawings. And basically the way she is presenting this is, as we've discussed previously, one of the big ideas out of this book is that can analytics be presented as microservices? And this is kind of the starting point, that you have some data domain and you have some way of connecting to send information into the domain and then to retrieve information out of the domain. And this is her sort of key definition. She calls it a data quantum. So it holds the domain-oriented data and the code that perform the necessary data transforms and shares the data and the policies. So one of the big differences here is, in the world of data mesh, there is not such a thing as data and then separate data pipelines. The pipelines are decomposed inside of the circles, which is something that I'm really trying to get some practical examples. And I'm going to be starting with the simplest possible one, which is around presenting data of a certain quality. So going further, I really actually like this representation. So this is a blow up of each of the circles. And this, if I look at it, it's like a classic microservice. In fact, if I didn't read the words, I would think that this was an application microservice.
Yeah, that's like you mentioned, the data quantum.
Yep.
Like I was maybe thinking the same thing, that why didn't you just call it a microservice or a data microservice, so it kind of better correlated, instead of inventing a new thing that is immediately mysterious, and then you got to kind of back into something that like at least functionally appears like a microservice, I guess. But
so when I look at this, the area that I am building for my first customer use case is around a subset of the activities here. And the subset, I think, is going to be relatively common, because one of the drivers of this technology is massive amounts of data. I think of it as lakes of lakes, if you will. So groups of data lakes and data warehouses. So massive amounts of data. So one of the key challenges is simply finding the data. And so when I look at this mini architecture, the area that I'm focusing on in my demo is the discover. How will the data consumers discover the data product? There's lots and lots of other aspects of this. And even though they're single words, they're like this transform, this is definitely oversimplified. This could be, n things, not just 3 things. This could be, 10 things. Or in my case of bioinformatics, it could be 57 things. It's a pipeline, right? It's a pipeline. And then the control, this is simplified in a way that is necessary, but it'll come back to bite you, because control at the level of the service, but how does that fit into organizational control? Mm-hmm. And that's another area that is early in this process, right? So the input output's okay. These other 3 verbs are not as solid at this point. Yeah. So then she comes and she shows the different planes. And what is important about this is which shared services is the data mesh going to use versus which individual services. And in the case of search, it's kind of a standard paradigm already in data analytics to have a data catalog. So one of the things that I'm going to show you in the demo is how, in the case of Google Cloud, in the data mesh services, which is Dataplex, how the data catalog is integrated into the Dataplex services. And that is actually my starting point, so that the consumers can search the mesh. And it helps to give an idea of the web, if you will, of interconnection between the experience planes and the individual services. This is drawn as if there's just somehow like a single line or something, and it's really much more complex than that. There's, a line here, a line here, a line here, a line here, a line, you know what I mean? So it's a web, if you will. Also, we've got these separate planes where you have mesh experience, which is observe, monitor, search. The product experience and the mesh experience is a little fuzzy to me. Product, I guess, in her case, is creating and reading. But to me, reading and searching go together as a user. And creating would be separate. So I wouldn't exactly draw it this way, because creating would be separate. I think that comes out of classic analytics, which is in a data warehouse, does somebody have read or do they have read-write? And then on the infrastructure, this translates to the services. And in the world of Google, the initial build of this, of their service that implements this, uses only 2 core storage types completely. There are some partial integrations with some other storage types, but the 2 core storage types are raw bucket storage, raw file storage, or data warehouse storage, which is BigQuery data sets. And those are the 2 types of storage. And I believe that's the same way with the other cloud vendors as well.
Seems to be Data Zone as well. You've got your Redshift world, you've got your S3 Athena world. That's kind of the universe right now.
Right, which I think really is helpful for me to think about this, because it's thinking about that lake of lakes, or there was called data lake house. So data lakes plus data warehouse is another kind of term for data mesh. So this makes sense to me. This not as much. I'm not sure about the read part of it, and then the lines are not drawn here. So here we start to drill in, and I like this. One of the things that I think is very significant here, and I am trying from an architecture hat to figure out what this might look like, is this idea of the yellow information is ETL, or transformational code, that is specific to that particular data product. So very specifically, if you had oh, I don't know, some sort of text files coming in, and they sometimes had nulls, and you wanted to convert the nulls to zeros for this particular data. It's kind of an old data warehouse thing. So for this data product, we don't allow nulls, we convert it to zeros. Okay, fine. This sidecar domain agnostic, this relates to policy. And this is where we get into this nuance of, okay, I thought we had a control plane up above for policy. In what cases do we use the control plane at the top level, at the organizational level, versus do we create sidecars? And
I think the concept is that the control plane kind of like is the control plane for the sidecars, right? That's how you would dispatch and kind of distribute the policies into the sidecars of the individual domains as described. Is that how you interpreted it?
A policy injector? I'm not sure.
Yeah.
What does that mean practically?
Practically, this is the part, and I had quite a few conversations and gave a talk on this recently that is the most abstract, and I don't understand how it would work from a kind of
I'm not. I can see that it seems like it would make sense, but I'm struggling coming up with practical. I think it's my inexperience with this. I'm continuing to work on it because it seems like a good direction, but I haven't been able to build anything that implements this sidecar yet. I've built this, but not this.
And I don't even know if she means for there to be an actual sidecar inside of a container. I think to a certain extent, maybe she's just using it as a metaphor, because I guess for microservice folks, or she kind of encourages people out of that context and understand that world and kind of the microservice paradigm. Like sidecars are known, and they have generally they are like something that hey, we built this thing from infrastructure, and you just deploy it next to your service, and it's going to do a lot of lifting that you don't have to worry about, so that you can distribute events, and everybody can distribute events the same way, or consume events and consume events the same way, or whatever, even other non-data specific tasks, maybe security related, etc. So I think it might be more of a metaphor, perhaps, but again, it's all pretty abstract, so it's hard to tell.
Right. And is it a script? Is it a Docker container? Is it both? I don't know.
Exactly.
I just need to build some. That I'm a builder. And then domain specific, that makes sense. And then interdomain, this makes sense to me, that you're going to have some things that are going in some cases and going out in others, and having dependencies. Yeah. That starts to reflect the real world, the messiness of the real world, and is why you and I get paid the big bucks for modeling, helping the customers to model, right? Because it's never straightforward. Okay, and then I particularly liked this one because this helps to see into the data product. So you have the ETL code, the API, discoverability, observability, computational policy, documentation. And again, some of this could be sidecar if it's repeated. Data, documentation, SLOs, lineage, policy again, specifications of infrastructure. Okay, so the platform dependencies are a separate, which would make sense because if you want to run it on multiple platforms. This is a very sophisticated architecture. Before I came into human health in bioinformatics, I did a lot of work with fintech. And fintechs have the resources to go multi-cloud platform. But I have had many customers who didn't have those deep pockets try to architect like this, and it was over-architected and really didn't provide them business value.
Mm-hmm.
So I would say that this is definitely the advanced class over on this side.
Yep.
So, all right. Then she goes to her, and I like that because it shows like a little ETL pipeline inside of a product. I'm really interested in operational efficiencies, and I'll take the data quality example because that's the one I've been exploring. So in the GCP product, the Dataplex set of services, there are a set of data quality tasks that are associated as templates. And I think the thinking is to support this type of architecture, that here's a template, you can just fill in your input, your parameters, your file type, and then you can run on kind of a serverless kind of compute architecture, basically. It's a Apache Beam under the hood, but it doesn't really matter. But the idea is it's almost like a, I guess, a reusable component that you can deploy into multiple data products. And I have found in discussing that with my customers that that's a really hard concept for them to get. This decomposing of the data pipelines and the putting the transformation code together with the data as a product, I think this is one of the biggest shifts in this thinking.
Yeah.
All right, so going on here, she kind of does the same thing again. Okay, with more words. All right, and here, I really like this. This is showing more the real world that you could have. I like this one in particular, multiple data products, because this reflects the way Google has set up, and I think Amazon did this too. So the idea is that you have a lake of lakes if you're using file-based analytics rather than tabular, and that you group the assets into zones. And the zones are either raw or curated. And raw means that the schema is not validated. Curated is there's some sort of schema validation, assuming file-based, that you want to do, queries on, so you need schemas, right? So the thinking here would be like, this would be a zone. And Amazon, I don't want to put you on the spot, but Amazon does it that way as well, doesn't it? Zones within lakes.
I can't speak to, honestly. I think the real concept of zones is being able to have, I don't know if the lake terminology really comes into play, but the concept is that zones can be stitched together into projects through like subscription almost, right? You have access to things, you can create new beta products virtually as projects. I don't know that they really, I think a zone might be equivalent to a lake. It's not completely clear.
Yeah, I think that it might be helpful. I did this when I was doing studying cloud quantum, for us to put together as a group a chart, because when you have these new terms, then the vendors will put their own spin on it, right? And it just makes learning harder. So if a zone means something in Google and a zone means something in Amazon, if we have a little chart, I know that's helpful to me. So maybe we can even get one of those Gen AI tools to generate it for us accurately. I don't know. They're not always accurate on some of the new stuff, though. Okay, so this is the area that I was building my POC, data discovery and observability. And again, my sort of twist on this is I really saw this as a control plane that's both search and read as an initial proof of concept. And again, I think this is my walk before you run approach to things. I think that the book, goes a little bit farther, like you would have the ability to both read and write and create a data product and all that. I'm like, nope. I just want to make an environment that's basically a super data catalog. That's what I'm going for as a starting point. A super data catalog, which is my version of the multi-plane data platform. So going on. Okay, yes. And again, the same diagram as before. She adds monitoring policies. I do like the fact of kind of having a simple diagram and then adding more detail. I think that's like a good teaching technique around teaching new technical concepts, sort of like peeling the onion, you know?
Yeah.
So create, deploy, set privacy, document, read, and then the infrastructure she adds. This is like all the cloud vendor stuff, basically. At first, she was just putting the service, but now she's putting the query engine, the identity. Yeah, this is well done, actually.
Yeah.
What do you think about this? Is this useful to you?
Yeah, no, I think it is. It's a little more fleshed out than the last diagram we saw of similar function, and it makes sense.
Well, I think about it in terms of teams. Like this would be the corporate IT would be managing this, right? The data product experience.
Be like a data infrastructure team who just supports the set of capabilities and develops them, right?
Well, I'm thinking about this. This is obviously like, you know, the organizational cloud infrastructure team.
Yeah.
The mesh experience would also be, I think, although this one client I have, they're medical, and they have an internal catalog on-prem with taxonomy, and that's a separate team. So that would be reflective of this, where you have companies that have, I almost call them like librarians, like data librarians, like they're doing the lineage, they're doing the taxonomy. If you have that team, that could be a separate plane. If you didn't have that team, then the same team would do this one and this one probably.
Are you pointing to the mesh experience?
Yeah, the data product.
Right, I agree with that. The data product I see is almost like, you know, a dedicated engineering team. It's almost like akin to developer experience.
Yep.
You know, DevX teams are building like these tools so developers can do less heavy lifting and use standards and frameworks and such. So I kind of think it's akin to that, maybe.
Yeah, I think so too. And in a smaller company, I think the mesh experience infrastructure utility would be the same team, and the data product experience would be the developers, basically.
Themselves, yeah.
Yeah. And the people who would be doing the microservices would be integration with the SMEs, the people who actually are the stewards of the data. So it would be not unlike way back when I was building data warehouses. It's just kind of in this new paradigm. You know, obviously I didn't build them on the cloud because cloud wasn't a thing way back then, but
yeah,
I can see it mapping. So
yeah. I think the thing is that middle plane, especially, and the top plane, until the cloud vendors really supply those components readily usable, I think this architecture is going to be prohibitive for smaller organizations.
I think so too. Well, it's I mean, you know, it's just cycles, right? It's like when OLAP data warehousing came out, it was prohibitive. It was like, just put up a second SQL server and make it read only.
Yeah.
You know what I mean? If you only have 2 people in your data.
Exactly.
You know.
But that might go with the organizational maturity too. If you got 2 people, what are you even talking about meshes for, right?
Exactly.
If you have a small development team, it's probably not time anyway. But I think in that mid-tier of companies, mid-sized companies, it'll be challenging without the where this would make sense, and it would be challenging to make their own infrastructure.
Well, the way I see it is, if companies already have data warehouses, whether they're on-prem or in the cloud, which I think most companies that aren't startups do, then the next critical question would be, do you have a data lake? Because if you don't have a data lake, I can see that this would be, I can't see it being relevant. You just would want to use your like Redshift or BigQuery, right?
If you're in your centralized kind of like data management maturity life cycle, right?
Right.
Yeah, that's all you're going to want.
Right.
So for more complex organizations that are operating, you know, in kind of, you know, either outcome-based or product-based teams, then like this just feels really good, right?
Well, yeah, or like in my bioinformatics world, where it's just so much data. We call it genomic scale data. It's just pounding amounts of data. It's just I mean, I don't know if I mentioned the story, but one client that I'm working with, their cancer tissue images right now are 3 to 32 gigabytes per image off the scopes. and they got a new microscope, and the new image resolution is going to result in images that are 1 terabyte.
Wow.
Yeah, and they get hundreds of them. So, and obviously then what they do to process that is maybe it's not obvious, but they tile them. And so that results in just massive amounts of data. So anyway, okay, so back to this. So the mesh experience plane here, again, I like this diagram because this, to me, I look at this, I go, oh, it's like almost a data mart.
Yeah.
And this is dating me here, like a little data mart here.
Mm-hmm.
Data mart, because I don't know, I'm older than you. I don't know if you were involved in this technology, but I was really very involved in OLAP. I wrote 3 books on the topic and data warehousing. It was kind of a new cool thing way back when. And it was analogous to DataMesh in that it was overkill for people. And so for a lot of my clients, I built data marts, which were like little mini. They were bigger than data quantum or data products, but smaller than data warehouses.
Yep.
So
you often had to create data marts for data warehouses too, because they were too big, too complex, and you needed something purpose built for the consumer.
Yep. Well,
yeah, I'm old too. I remember all this stuff.
Right.
And still deal with it today. Trust me.
100%. Well, I used to joke as a consultant that I would build a minimum viable report for the finance group. And then, obviously I would have a job forever because you give finance people accurate, fast reporting, and who pays your salary as a consultant? And so like when I launched out of my corporate job, that's all I did for 2 or 3 years is I created data marts because it was a fast way to value. So it's interesting how, although there are a lot of new ideas here, nothing is really new in the world. Because I look at this and I go, oh, this is a data mart in some ways. I
think the interesting thing, and I do think it's very much a data mart approach, only inverted, right?
Right.
Not to go back to like organizational ownership and everything, but here you're saying, I don't know if she labeled it, but let's say that this is like the playlist team. You build the data mart, right?
Right.
And you be the publisher, right? Which is novel, but in the end, it's very much similar in function, right?
Yeah.
Very similar in function.
Yeah. So, all right. So here she's talking about the sidecar more. So maybe I should reread my book that I'm supposed to be talking about. So sidecar is a logical component that decorates, separate process, loose coupling, injected. So, I guess my instinct was right. So some sort of policy injector, organizational level, and then this is the injected code. Okay, that makes sense. All right.
And she also talks about it in a way that, it's a, just like an idea, like it's conceptual, and it continues to talk about containers, right, and microservices. It's a reinforcement. But again, we'll see how it gets implemented.
Right. Okay, and then the container control ports makes sense. Okay, and then I really like the recap here. Again, I'm a drawing and table and chart kind of gal. So, domain analytical data interface, domain operational interface, data quantum, data container, data sidecar, input port, output port, discovery and observability, control, platform, infrastructure, product experience, and mesh. I challenged myself when I was working on my demo to see how much of this I could translate. And I couldn't translate as much as I thought I could. Because when I was reading it, I thought, oh, okay, I see that. So it'll be interesting because what I'm going to do now is I'm going to switch over to a public version. Obviously, I can't show any of the customer's proprietary stuff, but a public version of where I was going with my POC demo of the catalog to talk about the first aspect of a data product, making the product discoverable and readable. So anything else you want to say about this chapter before I switch over?
No, no, let's get to it. Let's see,
Okay.
see real life.
Okay. All right. Okay. So in Google, the set of services that are designed to enable data mesh are called Dataplex. And this went GA less than, I don't know, 6 months ago. And it came out of an internal beta. So it kind of came out of like nowhere really quick, right? Because it wasn't like a external beta. It was like, we have it, go for it. And I think Amazon was about the same. They were about the same timing. And Microsoft has Azure Synapse, I believe. And then they had an announcement around something called Fabric.
Yeah.
So it's interesting to me because when I look at Cloud Wars, the sort of hot topic obviously is Gen AI, which has eclipsed this. But this is a secondary hot topic, albeit much lower on people's radar. But
Yeah.
I would argue probably more impactful because Gen AI has a specific set of use cases that's expanding, but people don't understand them. Whereas the volumes of data that people are dealing with is exploding. And I think this is actually a more cloud addressable problem with these sort of technologies. And just from a very pragmatic point, my bioinformatics colleagues, you know, we have this thing, we call it bucket sprawl. And this is very, very common as my customers move from HPC clusters or university clusters or colos or whatever, and they've got, you know, 25 petabytes of data to start, right? And they're used to, you know, old-fashioned, you know, nested file directory structures, and that's their metadata. That's how they find things, right? And so when they move over to cloud and it's bucket-based, they literally just make tens and hundreds of buckets. And like I've seen the same thing so many times, and I've only been working in bioinformatics for like 5-6 years. But it's this sort of like, you know, she talks about the inflection point. That's an inflection point I see, which could drive data mesh adoption.
Yeah.
Literally, people just cannot find their data because it's sprawled across projects, across buckets. Now, I think this is less.
Is this also like a data sharing issue though?
Oh yeah. Oh yeah.
Yeah. So it's not just they can't find their own, but certainly other people couldn't find it.
For sure. And the other thing that makes it worse is it depends on how the cloud vendor implements service boundaries. So, you know, as we all know, buckets, no matter what cloud, because of their high availability, they have globally unique names because they're typically replicated 3 to 5 times. So it doesn't actually matter in some cases in which zone you put the bucket, but how that is used by the user differs by cloud vendor. Amazon, of course, not having a concept initially of a project, just basically saying a service, S3, get the bucket name, you're good to go, right? So I see this as less of an issue in Amazon. In Google, Google has a concept of a project. And a project is a container for services, and it can be in multiple regions. So it's very different than Amazon. And so, you know, if I looked at my buckets in this particular project, they would be different than my buckets in this project.
Mm-hmm.
And that's what I mean, even
So
though,
depending on your context, which project you're logged into or using, you've got an even bigger problem because these buckets could be sprawled across tens, maybe even more projects.
Yeah. Well, it depends on which interface you use. I mean, commonly, you know, non-technical users will use the web UI, right? When you have so many buckets and you can filter and you can find things in here, right? And so that's what they would use, right? But if you use scripts, then this problem goes away because if you use a script, you're just, you know, getting the bucket information, and the bucket path does not include the project because it's globally unique. But the point still is, for a user who's used to directories, when they switch to bucket-based system, my experience has been this interface, although sometimes useful, hits a limit point when you get hundreds and thousands of buckets. So again, this might be very, very specific to genomics, right? Like, because of the amount of data, but this is just a problem that I'm seeing. So anyway, so inside of Dataplex, the idea is basically you have a Google for your buckets that you can search. It's really just that simple. And it's a integrated web UI that allows you to search across multiple projects, multiple lakes, multiple data sets, including even public data sets. So that you have, if I want to look for COVID public data, the data could be under public data, or it could be under my own data somewhere. Now, one of the things that's really interesting about this is you can see right now I've got all this BigQuery data. So these are BigQuery tables. And technically what BigQuery tables are is it is file-based storage. It's in a bucket type of system, but it has associated schema with it. And it's optimized as by Google. So it's placed closer to where the query engine is. So you have less latency. So I think of it as, they technically call it a BigQuery data set, and you cannot just natively query Google Cloud Storage with BigQuery, although there's a way you can put a link. But basically you have cloud storage, and then you have BigQuery data sets. So it's interesting talking about the compute being close to the data, or a part of the data as a data product.
It's kind of a quantum already, the way you described it, right?
Yeah, because if I click on it, because it's a type of a structure that has associated compute with it, you can just go ahead and open it in BigQuery, which is what you'd want to do with it. And then you can just query it. So you have a data quanta here, basically, right?
Yeah.
Because you have serverless compute, so the Amazon equivalent of this would be Athena, right? That you're only charged by the amount of data that's queried, right? So if I go, it's like $5 a terabyte or something like that. And then, so it's like a SaaS implementation. There's no, you don't run any, operating systems, you don't run any database engines, you don't run any clustering, that kind of stuff. But that's not new. The new part is the data catalog is exposed in a single location. Which I don't know how this is done in Amazon. I'm sure they have it, but I haven't. So I'll put it out there to you, since you're working at Amazon more than I am right now. One of the things that is interesting, though, of course, is what is Google's core business? Search, right? So they're going to be very, very good at search. So the way the data catalog works is it assumes certain types of data structures. So BigQuery and cloud storage. You can also use PubSub, which is like a SNSQ, basically a stream. And then you use, this is old technology, new again. This is basically Hadoop. So DataProc is highly optimized Apache Hadoop and Apache Spark. So it would be the equivalent, Amazon equivalent of EMR, basically. And the Metastore is a library that was used on Hadoop to make Hadoop SQL-like. It's called the Hive, or the HQL. So it was where you put schema for files so that you could have scalability beyond your data warehouse and cheaper, right, into your Hadoop system. So what is done here is to use the data catalog as part of the Dataplex services. It's required that you create a Hadoop DataProc Metastore, and that's where the metadata is stored and it's queried. And then they have integrated into this, kind of interesting, kind of, again, taking the the data mesh concept, this first level of data quality, and there's multiple levels, and this is data loss prevention. This is scanning. And so you can scan for different types of sensitive information as a sort of a data quality check. Because the thinking is you'll have your raw data coming into your buckets, and then you'll have your curated data and BigQuery data sets. And that's why you would scan your BigQuery data sets as a check. Like in my case, to make sure there's no personal health information, PHI, right? And then notice you can also put non-data assets into the catalog. So the way this works is inside of Dataplex, the set of services are around, first around search. This is search using the web UI. The Explorer allows you to run search with using SQL queries against anything that's in the lake, and you have it by zone. And notice the engine is Spark SQL because it's running against the Dataproc Metastore. So it's scalable search across any of this. So you could basically, it's kind of the Google approach to indexing the internet, but to your data mesh, which to my client is going to have great value, because once either the IT team writes these queries, or we train a large language model so they can write them in English or whatever, this will allow search across the entire data mesh, which is pretty great. You know?
Quick question. I noticed you have a context of a lake.
Yeah.
Right? Are you, if I discovered content from several lakes that I wanted to then work with in this editor, is that possible, or do you always have to have the context of a single lake?
I think right now it's a single lake, but of course customers want multiple lakes, and so it's on the roadmap.
Yeah, because that's where you'd be thinking about these derived like data products, right? The listeners might be here, the playlist might be in a separate, we'll use lake as a term.
Well, the way they implement this is through zones in the lake. So now,
so a lake is a higher level container.
Yeah. So right now
Interesting.
the idea would be like a whole product unit. So like, I'll just take an example. If I have one customer that has, you could do it by business unit. So like research versus clinical. You could do it with who need a security boundary. You could do it at the lake level. You could do it by lab, because sometimes there's different security between the different research labs, because they don't want somebody else to get their work, right? So the lake is a hard security boundary.
Could you have the same content within two different lakes?
You wouldn't want to. You'd link it. You don't want to copy. Yeah. And then
right, definitely not copied, but you could link. I could link in data from another lake.
Yes.
Into this lake, and then it would be accessible.
Yep. Awesome. So by default, you get a Spark SQL query, but you can also have custom environments. And this goes to if you want to use custom libraries for scaling search. And so this is all Hadoop technology. So anyway, so you have this quick and dirty web UI with the filters.
One last question. Yeah. Is it Spark SQL because and not BigQuery, because we're actually going to run processing on top of data that may be in different storages? Maybe they're in cloud storage, maybe they're in PubSub.
No, that's a great question. The reason it's on Spark SQL is because the metadata is in Dataproc, which is Apache Spark. So the information about the data is stored in a Spark server. And
does the Spark server automatically know about like your big data repositories and their metadata, or is that stuff you have to manually?
Well, isn't that, your timing is impeccable, my friend, because that was what I was going to show you next. So you have Discover, right? Well, how do you get that data into the Metastore, right? So here's this section, managing the catalog. So the catalog is this thing, right?
Yeah.
And so what you do is you work with different types of tagging. And so you have tagging that's associated to processing. You have tagging that's associated to governance. And Google provides you with default tag templates. The easiest one to understand is the geo context, like where's the data from. So then you can specify, you create a tag template. And Amazon to me does tagging more completely than Google because they had tags as, they didn't have project boundaries, it was tags. And so my Amazon customers understand tags a lot better than my Google customers. So this is tags that would be required by policy for a specific use in terms of governance. Like, for example, if you had GDPR or something, right? Like any data that's in EMEA, do this. Any data that's in North America, do that, right? And you can notice you can search for entries using this template. So see? So, so you create the tag templates, and Google provides you with default templates that you can use, but you can create your own. So this is like, to me, a very fancy version of what I've seen Amazon customers do for a long time, to be honest with you.
Is this DLP behind the scenes, or is this?
You can wire the DLP to it.
Okay.
So this is basically for identification, right? So like for the data quality, you can see here which fields will be added.
Okay, got it.
Okay, and then you can customize as well. So the difference here is these templates are more around governance.
Yeah.
So then the next concept is an entry group. An entry group allows you to group cloud storage assets together. So the whole idea here is to be able to deal with bucket sprawl and do something about bucket sprawl. And in order to understand this, this is where I talk about, us making a table of the different terms would probably be helpful, because I had to look all this stuff up. So for Google's implementation of the data catalog, you have project location, and then you have in orange there, you can create entry groups. So entry groups allow you to map data assets to entries and entry groups. And notice you're mapping into the Dataproc metastore, right? So the idea is that's how the information gets in. You have to define what it is. Certain things will get in automatically, and then other things you want to define manually. And it's probably easier for me to show you an example. So if you create an entry group, you just say where it is, basically. And then inside of the entry group, you create an entry, and an entry is a bucket. Once you create an entry in an entry group, it basically adds metadata to a bucket. And what you can then do is you can take a subset of the data in the bucket. So file patterns, so types of files, for example. If you have buckets with just random files in them, and you care about a certain file type, like anything that is, in my case, a VCF, which is a variant calling file, which is the end result of genomics processing. If I care about all my VCFs, I don't care about all the middle files, then I would say, star.vcf basically in here. Now, there's two things you can do. You can take a subset of files by type in a bucket and just leave it at that, and then you can scan those, you can, set security on them, so it's a way to slice within a bucket. Or you can also define a schema on that subset of files in the bucket. So this is gets into the territory of Amazon Glue, where you have schema inference and schema updating and schema validation.
Yeah.
Um,
I was wondering if there's a crawler for this, or do you have to add the schema manually at this point?
At this point, you have to add it, but there are other services that you can generate it. So there's something like Glue, but it's a separate service. I haven't used it. I did a project with Glue way back when it first came out for a finance group, where they were bringing in feeds. It was trading in New York, and they were bringing in a bunch of different feeds. And what they were doing is whenever the schema changed, they had a whole team of junior analysts to rewrite their scrapers. And they were trying out Glue with the automatic schema inference, and it worked.
Yeah, it's pretty good.
It was pretty good, yeah. So anyway, so file set, once you have it, then a file set is, in this case, what I did is I defined this type of file. It's called a BAM file in here. And then I associated the geotag with it. Again, I'm just making fake examples, basically. They don't make any business sense. Now, inside of here, you can see it links back to the original bucket. And Google's very good for that, right? So, you know, this goes to your question of how do you get the information in the DataProc Metastore? The basic high-level answer is these three sections here.
Yeah.
Now, in addition to what's in the web UI, there's an API. So there's an API around data catalog. And as is the typical case with newer Google services, you want to go beyond the web UI, and you want to also explore the API, because more capabilities will be there in terms of than what you see in the web UI. So I actually think this is a probably good, oh wait, I got one more thing to show you and then I'll pause. So I don't know if you've ever seen this tool. It's a subscription tool. It's called MindMap. It's a mind mapping tool. And this is just what I use to understand complex systems, because I have to put them in hierarchies in order to understand them. So when I'm trying to work through this, I didn't really get into BigQuery at all, but BigQuery has a whole set of services. Like I was saying earlier, if you have no data lakes and you have data warehouses, you have no business, in my opinion, in Dataplex. Dataplex is, you must have at least one data lake and at least one data warehouse, or multiple data lakes, or it's overkill, I think.
Yeah.
I think. So if I collapse this, and then I bring out Dataplex, let me just make this smaller. The two areas that I think of are data catalog and the Dataplex for processing tasks. And that's because of my particular use case. So then if I try to map this, if I expand this, you can see here that we have this mapping between the DataProc Metastore and the entry groups. So the file set maps to a bucket, to a file pattern.
This is helpful.
Oh, good. Yay. So in the next implementations, we'll be talking about what the data lake gives you and this kind of stuff. But this was helpful to me to figure out the mapping, because I was like, I don't know what maps to what. So you're not copying, you're simply adding information, and it goes into the data catalog. So again, I'm still obviously working through this. It's a big nut to crack, but it starts to give a little bit of tangibility to some of the ideas in this chapter. I certainly haven't handled much of the processing or anything like that, but it just is mapping to what I'm actually working on with my customer. We talked about in the next one, we'll be getting more into data as a product. So I'll be looking at the transforms and stuff like that. So that's what I'll be building this out. And then I twisted your arm, and at some future point, you said you might be showing us some data zone.
Yes, absolutely.
Great, fantastic.